All right, so let's look at some more examples of our compound inequalities, the ands and the ors. Example 4, we can see it's all connected. This is going to be your and inequality. Just so you know, if it's an or, they have to write out the word or for you. An and can be written out, or it's going to look like this. So our goal is to go to the center where the x is and solve for x. You can see plus 3, so we're going to subtract 3. Don't forget to do that from all three sections. So negative 2 minus 3 is negative 5, is less than or equal to negative x, which is less than 1. Now to get rid of that negative, remember, you can put a 1 in front, so it's like a negative 1. So we're dividing everything by a negative 1. Now, if you remember from earlier in the chapter, if you divide both sides or all sides of an inequality by a negative number, it is going to flip the inequality. So this becomes a 5, turns into a greater than or equal to x, which is greater than 1 divided by negative 1 is negative 1. Now what we're going to want to do is just take this whole thing and flip-flop it. So this negative 1 is going to go here. You still want the inequality to point to it. So do you see how this is pointing to the negative 1? It's still pointing to the negative 1. So basically everything just flips over so that we get this in the proper order. Flip that over and then 5. Basically with your and inequalities, if it's all connected like this, you want these to be less thans. Alright, in a graph we have negative 1. Here's where 0 would be. 5 is going to be out here. We're going to have an open circle at negative 1, a closed circle at 5, and because it's an and, we're shading everything in between. Alright, next one, we got a little, well, it's an or, so we're going to solve. You can kind of think of it as two separate problems. Solve the left one for y and then solve the right one for y. So on the left, we're going to subtract 7 first. Remember, you're always adding or subtracting your numbers first. Negative 2y is less than or equal to negative 6. Divide both sides by negative 2. There we are dividing by a negative number, so y is going to be greater than or equal to, we had to flip our inequality, a positive 3. I'm going to go ahead and bring down the word or, because now I know we have to solve the other side. So first thing I'm going to do is get this y to the other side by adding y to both sides. So we have 4y plus 10 is less than 4. Subtract 10, so it's just like our regular equation solving. 4y is less than negative 6. And then divide by 4. So we have y is less than, now that negative 6 over 4, we can divide those by 2 and just reduce the fraction and get negative 3 over 2. So here's our inequality. Y is greater than or equal to 3, or y is less than a negative 3/2. So the 3 is positive, so I'm going to go ahead and put that here. Here's our 0. So the question is, where is negative 3/2? That's the same thing as a negative 1.5. So here's negative 1, here's negative 2. It's going to go right in between those. That's your negative 3/2. I'll write it in a different color so we can see it. Okay, so now we need a closed circle at 3. An open circle at negative 3/2, and it says it's greater than or equal to 3, so we shade to the right. And then this one says it is less than negative 3/2, so we shade to the left. And there's our or inequality shading in both directions. All right, last one. Here's another or, so we can predict what it's going to look like on a graph. We'll go ahead and add 1 to both sides. Remember, we're going to solve these separately. So 2, I'm going to change that to an x because I don't like z's, is less than or equal to 6. Divide by 2, and you have x is less than or equal to 3. Or, now let's solve the next one. We'll add 5 to both sides. 3x is less than or equal to 15. Divide by 3. It says x is less than or equal to 5. Alright, so this one's going to look a little bit different. If we graph this on the number line, here's 3. Closed circle, because it says x is less than or equal to 3, so closed circle, and this is going to shade to the left, less than or equal to. Alright, then we also have a 5, so here's 5. is x is less than or equal to 5, so here's a closed circle, and less than is going to go that way also. So because this is an or inequality, we need to know where the x's are less than or equal to 3 or where they're less than or equal to 5. So if you notice, here are the x's, we're shading all the ones to the left of 3, but we're also shading the ones to the left of 5. And the ones to the left of 5 include those ones to the left of 3. So we're just going to say our answer is all the x's can be less than or equal to 5. So we do have to think about these a little bit. You know, if it's not doing the obvious shade to the right, shade to the left, like most of our or inequalities over here, you have to think about what your final answer will be like that.